Hi, welcome to Unacademy YouTube channel. Good evening, everyone. Anyone is there? Are you audible? Are you there, boys? So, everyone, welcome to. So, everyone, welcome to Unacademy YouTube channel. So, for getting subscription features and everything, you can see the description given in the below link about everything in the given description. Below that, in description, it is given. See that and see our special classes also daily from 6 p.m. to 7 p.m. you can join. And also one thing, and every Sunday marathon class is there, morning 10 to 11, 10 a.m. to 11 a.m. marathon class is there. I will keep the link on next class. Okay. Tomorrow also marathon class is there. You can download our Unacademy Learn app. Okay, and subscribe. Okay, guys. So tomorrow in marathon class from 10 a.m. to 11 a.m. So very important model MCQs, previous MCQs on laws of motion. Laws of motion MCQs tomorrow. So don't miss everyone. You can join and you can, if you are a first time user, you can use the code when you are entering into the class. First time you can use the code Kiran P Live or Kiran MSC 08-5140. You can use this code also, no problem. So who are here in live class? So just you can message here once. I will notify you are there. Okay, let me know who are watching here. So you can use Kiran P Live. Or see, use this code. Okay, Kiran MSC 08-5140. So use this code to enter into the class. Okay, everyone? Okay. So let us start our topic. Right? So in last class we have started electric flux and gas law. What is electric flux and gas law? So gas law is what? Total electric flux around a closed surface is equal to what? 1 by epsilon naught times to the net charge enclosed through it. The total electric flux through a closed surface, integration of E bar dot ds bar, it is equal to 1 by epsilon naught times to the net charge enclosed by it. Okay, net charge enclosed by it. So here total charge means always we have to take in a closed surface only. For example, here it is a box. Outside a charge is there. So due to this charge, what is the flux here? 0. Because net charge is here 0, we have to take net charge. 0 we should take. Because always we should consider a closed surface like spherical or cylindrical mainly. Okay, mainly these two surfaces means to find the flux we have to consider what? A closed surface which is called Gaussian surface. Okay, and this is the gas law. The total electric flux around a closed surface is equal to what? 1 by epsilon naught times to the net charge enclosed by it. Net charge enclosed by it. So, for example, mm, see, this is a cube. In a cubical surface, see at the center a charge is placed. A charge q is placed at the center of a cubical surface, a point charge. Now, what is the total flux with the cube? Total flux equal to what? Total charge q by epsilon naught, because q is inside. But see, what about the flux linked in each surface? In each surface. See, for total 6 surfaces. See, generally cube is having what? 1, 2, 3, 4, 5, 6. Left, right, top, bottom, sides. Na? So, total 6 surfaces. For 6 surfaces, it is what? Q by epsilon naught. So, that for each surface, it will be what? Flux equal to Q by 6 epsilon naught. Because already it is in inside. So, directly inside we can apply. Because it is in closed surface. For example, if the charge is placed at one of the side. See, if one side charge is placed here or here it is placed, then how can we find? See, like this. One side is here, charge placed for cube. So, to find total what? We have to consider a closed Gaussian surface like this. Like this we have to consider. Now see, now the charge is in, see, if you place it side, if you place it the side, what happens is this is in outside. So, to find the flux what we have to imagine, consider another identical Gaussian cubical surface here with the surface. See, now to close this, these two are enough. So, with these two, the total flux will be what? Q by epsilon naught. Now, for each cube, what is the flux here? For two cubes it is na. So, for a given cube what means each individually, for two cubes it is na, for one cube means Q by 2 epsilon naught. This is what? Q by 2 epsilon naught. Like this we have to find. Or say suppose if the charge is placed at a corner. Suppose see at one corner it is placed. At one corner. See, generally cube is like this, na? At one corner, imagine. One corner it is placed, na? So, to close the charge, how many surfaces we need? See, for all corners, we should close that, right? For all corners. So, totally what? 8 corners, right? In 8 corners, in one corner it is placed, means 7 corners we should close. That means here 7 surfaces, identical surfaces, we have to consider 7 identical surfaces. Now total for what? 7 plus 1 for 8 surfaces. Flux will be what? Q by epsilon naught. So for each surface means for 7 cubes or sorry for 8 cubes it is. We have to consider 7. So total includes this one what? 8. See, imagine total 7 we should consider closed cubes. 7 plus actual is what? 8. For 8 cubes in between it is there. So for 8 cubes what? Q by epsilon naught. So for each given cube, flux will be what? Q by 8 epsilon naught. Q by what? 8 epsilon naught. Like this we have to find. Okay. Is it clear, everyone? Who are here watching? Let me know once. So, with respect to corner, that is. Okay, now. So, if the same, you have to consider flux through one phase opposite to the charge. So, in this system only, now one phase opposite to the charge. One phase opposite means remaining what? Three phases remaining. So, you have to take what? Consider three phases now. Okay, one phase opposite means remaining three will come. So, for 3 will come means what? Flux through each phase will be what? By 3. Q by 8 epsilon naught by 3, that is Q by 24 epsilon naught opposite to the phase. Flux through what? One phase opposite to the charge. Opposite to the charge. Why? See, we can see opposite to the phase of the charge. What is that? One phase opposite to the charge means we can see what? Only three phases. So, for three phases, it is by 3 each. So, it will be each Q by 24 epsilon naught. Like this, we have to find the flux. Now, by using this Gas law, we can find what? Electric field. You can find the electric field with a different continuous distribution of charges. See, for continuous distribution of charges, we have to take three types of charge densities. See, along lengthwise. If charge is what? Along lengthwise. We have to take linear charge density. Linear charge density. Lambda equal to charge per unit length. So Q equal to what? Lambda into L. What is the unit? C? Coulomb per meter. Okay, now? Or we can write d lambda equal to, lambda equal to dq by dl also. So that dq equal to lambda into dl for variable. For variable, we can write like this. And next what? Along area wise. Along area wise means surface charge density. Sigma. So surface charge density sigma equal to charge per unit area. A or S, no problem. Surface area. You can take S also. Okay. S also you can take, no problem. Surface area. So charge Coulomb per meter square. It is Coulomb per meter. It is Coulomb per meter square. So Q equal to sigma S. Or sigma equal to dq by ds also variable. So dq equal to sigma into ds. Okay. And along volume wise next. Along volume wise, volume charge density. Volume charge density rho. That is rho equal to charge per unit volume. Coulomb per meter cube. So Q equal to what? Rho into V. Or rho equal to dq by dV. So dq equal to what? Rho into dV. Like this we can see. We can find what is it? Field due to a spherical shell and a solid sphere. solid sphere we can find. This is very important for objective purpose. Okay, uniformly charged sphere or non-conducting solid sphere. Non-conducting solid sphere. See, non-conducting solid and conducting means what? Charges are vacant. Here, non-conducting means charges are fully, so it cannot conduct. Fully, it has continuously. See, consider. So, non-conducting means here at every point it has charge, means along volume wise. So that you have to consider volume charge density rho equal to Q by V. See, consider what? A solid sphere having the radius R. See, continuously having the charges. Now take a point outside the, see, consider Gaussian surface outside having small r. So small r is what? Greater than capital R. In that case, apply the integration of EDS. See, consider field and surface area vector are same direction, so cos 0 1 always equal to Q by epsilon naught. So E into integration ds. What is the integration ds? Surface area, which we have considered with small r, right? So 4 pi small r square equal to Q by epsilon naught. So E equal to 1 by 4 pi epsilon naught Q by r square in vector form into r cap. Or see, if you substitute Q value, see, rho equal to Q by, what is volume? Charge is up to, here total charge up to capital R. So Q equal to rho into 4 by 3 pi r cube. Substitute here in E, 1 by 4 pi epsilon naught into, see, 4 by 3 rho pi r cube by r square. See, 4 pi gets cancelled. What is remaining? See, rho by epsilon naught into r cube by r square. See, from here or here, E is what? Proportional to 1 by r square inside. Sorry, outside. Okay. So next, consider the point on the surface. Who is there? Anyone? See, next what? You can consider the point small r equal to capital R. See, this is sphere now having radius r. So here only we have to consider. So in that case, see, we have E equal to 1 by 4 from the first. Q by small r means capital R square. Or rho by, see here, rho by epsilon naught into capital R cube by small r square is capital R square only. So E equal to what? Rho by epsilon naught into R. Constant. It will become constant. And now the next case is what? Inside. That is very important. Small r is less than capital R. See, this is the sphere. Having radius r. But see, you are considering a point which is what? Less than. So up to here only we have to take the charge. So how can we find? Up to here, what about the charge? Q net. Total charge by total volume into corresponding volume. So total charge by total volume 4 by 3 pi r cube into corresponding volume 4 by 3 pi small r cube. So Q into small r cube by capital R cube. Now the integration of EDS Q net by epsilon naught E into what is S here 4 pi r square equal to what is Q net here Q into small r cube by capital R cube. First of all, without that, what it is? Q net by epsilon naught. So E equal to 1 by 4 pi epsilon naught Q net by R square. Let's see here 1 by 4 pi epsilon naught. Q net is what? Q into R cube by capital R cube into your R square. So it is 1 by 4 pi epsilon naught into Q into R. See, by R cube. That is here it is proportional to R inside. Or if you substitute Q value again, what is Q value? Rho into 4 by 3 pi capital R cube, right? To small r by capital R cube. See, R cube, 4 pi get cancelled. What is remaining? Rho by epsilon naught into 3 rho into R 3 epsilon naught. So this is also we can take. See here also proportional to R. That means see if you draw a graph here. First of all, see inside what it is directly proportional. Right? Inside directly proportional to smaller. So straight line. At the surface what? Constant it is. At the surface. Constant. And then what? Inversely proportional. Outside. So it will be this graph. Inside. On surface. Outside. So like this we have to find. We can represent it graphically. Okay. So this is the method to find. This is what? Electric field intensity due to a uniformly charged non-conducting solid sphere. Okay. Right. So remaining we'll see in tomorrow class. Okay, na? So bye all of you. In next class we will continue this. Okay.